Welcome, my friends. In this video, I'm going to derive tangent of the common angles on the unit circle. So here I have the first quadrant of the unit circle. Now recall that tangent is just equal to sine over cosine, or just y over x. So we can find tangent of all of these special angles on the unit circle by just taking the y-coordinate and dividing by the x-coordinate. Let's start with tangent of 0 radians. At 0 radians, the y-coordinate is 0 and the x-coordinate is 1. And tangent is sine over cosine, or y over x. So tangent of 0 is going to be the y-coordinate of 0 divided by the x-coordinate of 1. 0 divided by 1 is equal to 0. So tangent of 0 is equal to 0. At pi over 6, the y-coordinate is 1/2, and the x-coordinate is square root 3 over 2. That means that tangent of pi over 6 will be the y-coordinate of 1/2 divided by the x-coordinate of square root 3 over 2. We can reciprocate the denominator and multiply, so that we have 1/2 times 2 over the square root of 3. The 2's will cancel, and we will be left with 1 divided by the square root of 3. Now this is considered to be in an improper form, because we don't like to leave a square root in the denominator. So we can rationalize the denominator by multiplying by the square root of 3 over itself. We will be left with square root 3 in the numerator, and the 2 square root 3's in the denominator will cancel the square root, so that we are just left with 3. Our final answer is that tangent of pi over 6 is equal to square root 3 over 3. Next, let's go to pi over 4. Tangent of pi over 4 will be the y-coordinate of square root 2 over 2 divided by the x-coordinate, which is also the square root of 2 over 2. When we divide something by itself, we will just get 1. So tangent of pi over 4 is just equal to 1. How about pi over 3? At pi over 3, the y-coordinate is square root 3 over 2, and the x-coordinate is 1/2. So when we take y and divide by x, we will get square root 3 over 2 divided by 1/2. We can again reciprocate and multiply to get square root 3 over 2 times 2 over 1. The 2's will cancel, and we will be just left with square root 3. So tangent of pi over 3 is just equal to the square root of 3. Okay, last one. At pi over 2, the y-coordinate is 1 and the x-coordinate is 0. So tangent of pi over 2 is going to be 1 divided by 0. But of course we know that we cannot divide by 0 in mathematics, so that means that this quantity is undefined. Tangent of pi over 2 is an undefined value, so we cannot actually evaluate tangent at pi over 2. Let's summarize all the values that we have derived so far. So tangent of 0 is equal to 0. Tangent of pi over 6 is square root 3 over 3. Tangent of pi over 4 is 1. Tangent of pi over 3 is square root 3, and tangent of pi over 2 is undefined. Now, hopefully at this point, you have already memorized your coordinates for sine and cosine on the unit circle, so you already know the x and y coordinates for each of these angles. Your next task is to memorize all those angles for tangent. And the way I remember this is I kind of associate tangent with sine. So you might remember that sine increases as you go up the circle. We have 0, 1/2, square root 2 over 2, square root 3 over 2, and 1 for sine, or our y-coordinate. Tangent is very similar because tangent has sine on the numerator. So we are still going to increase as we go up the circle. We start at 0, and then we have not 1/2, but square root 3 over 3, and then 1, and then just square root 3, and then finally an undefined quantity. It's definitely worth your time to memorize the angles for tangent, because they come up very frequently. You could always rederive them from sine and cosine, but it's a lot easier to just have them handy anytime that you need to use them. Now, we can use tangent of any of the common angles in the first quadrant to derive tangent of any of the common angles in the second, third, or fourth quadrant. Here's what tangent of all of the common angles on the unit circle look like. So instead of expressing x, y on each of the angles on the unit circle, I just have tangent of theta. The way I think about this is that any angle in any of the other quadrants corresponds to some reference angle in the first quadrant. So for example, 150 degrees, or 5 pi over 6, corresponds to 30 degrees, or pi over 6. Over here, we are 30 degrees above the positive x-axis, and over here, we are 30 degrees above the negative x-axis. So tangent of that angle is going to be exactly the same, although the sign could be switched. So in this case, tangent of pi over 6 is square root 3 over 3, and tangent of 5 pi over 6 is negative square root 3 over 3. How do you know if you will be negative or positive? Well, just think about the signs on y and x. In quadrant 2, the y-coordinate is going to be positive, and the x-coordinate is going to be negative, so that when you divide them to get tangent, you will get a negative number. In the third quadrant down here, tangent is going to be positive because both x and y will be negative. And in the fourth quadrant, x will be positive and y will be negative, so that when you divide them, you will get negative values. We will have plenty of time to practice tangent of any of the common angles on the unit circle in the coming videos. But for now, I recommend that you memorize tangent of the common angles in the first quadrant. That will help you quite a bit throughout the rest of your trigonometry class.